Hello again. This would be part 5, I think, in our solar series. Eventually I'm going to quit identifying which parts, and you'll just know by what it says at the top of the video. But the last scene, we looked at the charge control unit, one of two. Those basically harvest the energy from your solar array, or arrays as the case may be, and then regulate that power to deliver to your batteries for charging purposes. Those batteries then become a source of power to your inverter, which feeds power into your home. That inverter also harvests electricity from your generator and or utility as is needed, and because it's smart, has a brain, it knows where the priority of energy is to come from, whether your batteries are the preferred source or the utility, and it will harvest as much as it can from one place before it goes to the other. Anyway, another key part of the system, well, maybe key is not the best way to put it, because the system should operate without this. But this is going to make things a lot easier for you. This is the Xantrex control panel. And if you've gone through the trouble of buying an array of several hundred watt solar panels and deep cycle batteries and an inverter, this is not going to be one of your more expensive parts of your shopping list. This runs about, I think, $250 give or take, and this, like most of the other Xantrex components, will network into your system, again with the RJ45 connectors on the back, and allow you to interface with the other devices from somewhere else in your system. You could mount this next to the inverter if you wanted, or if your inverter's down in the garage or out in a shed and you want this in the house where you have quick, easy access, you could do that, as long as you're not exceeding the maximum lengths of the network cables. I'm not sure what that is, but we'll find out shortly. I would bank that it's definitely not more than 300 feet, although it could be a lot less. We'll find out. Anyway, it has a little fault warning light here, a standby indicator, enter, up, down, and exit. And then it has a small, like 1.5 by 2.5 inch display, and there'll be various operating parameters, statistics, and alarms, whatever, if the case may be, displayed on here. And I chose to get one of these mainly because at the time I hadn't quite decided where to mount the inverter. I had thought about putting it down here in my shop, but the more I think about it, the more I think cable length to the main part of the house where the distribution equipment is might make this location prohibitive for that. Not to mention my walls, if you haven't seen them, in my shop are mostly cinder block. Most of this stuff here is basically hanging on a 2x4 resting on top of that cinder block. And so getting into the wall to mount 100 pounds of equipment is not going to be easy. So we may just rely on a wall stud upstairs to accomplish that. Anyway, again, Xantrex master control panel. They also make a generator start control panel. Looks very much like this. I think it might be a different color, and that is required to have the system control your generator for you. It runs about roughly what this does, and it adds that extra feature to your system in that it has the signals and the programming inside of it to call for a generator when it's required. So the next video in the series, not sure what we're going to cover. I have a couple things in mind. In fact, we may just get to them right now if we can do that. Let's see here. Down here we have a few more goodies that we haven't gotten to yet, and you probably can't see these, but these are DIN rail mount circuit breakers. And these are special DC rated for the purpose of PV systems. I've seen other circuit breakers by the same manufacturer that have better ratings than this even, but for some reason the solar companies want to sell you this. This is a 150 volt DC 20 amp circuit breaker that mounts on a DIN rail, 35mm DIN rail, and your solar modules on your roof or wherever you mount them will come into here before they go anywhere else in your system. So you'll mount these in a box in close proximity to your solar modules, and that box, in this case, we purchased a Midnight Solar box, and it is called a solar combiner, and these run about a little under $100 before shipping if you can't find one locally. And you'll look inside and it looks like a very plain 6-pole distribution panel. Not a whole lot to it. If I were to remove this black cover, what you would see is a little DIN rail back in there for mounting your circuit breakers on, and what it then does is it has some large bus bars and termination lugs for your main power to come out of here. So what will happen is you'll have however many PV circuits. In my case I'll have at least 6, maybe 7, in which case I'll need to add another box. And each circuit will go through a 20 amp circuit breaker, come out of the circuit breaker to a main bus lug. From there we'll have a single set of cables coming out of there, coming into our charge control units. In my case I'll have 2 of these, because I have 2 charge control units, and each one has to have a separate PV array on it. In other words, you can't have the same PV arrays feeding 2 different charge controllers. So what I'll do is have 2 of these side by side, and I'll probably have 3 solar arrays on one and 4 on the other, and though each one of these will feed one of my charge controllers. And we'll have 2 battery strings. I am not yet sure if we're going to combine the battery strings and the solar chargers to have the 2 strings in parallel, or if we'll keep them separate. For load sharing purposes, my preference would be to tie the 2 strings together so that preferably each string is loaded fairly equally, but we'll have to find what the manufacturer recommendations are for that. So far I've not found anything prohibiting us from doing that, but we're going to continue looking. These are our end brackets, end clamps for the solar panels themselves. And if you can see that, this mounts to a DIN rail type structure. In this case, these are made by a company called Unirac. Okay, and Unirac makes brackets and rails specifically for solar panels. I don't know if we have a local distributor of Unirac in Tulsa, but we're going to find out. Unirac is very quality, high-end product. There are many types of rail brands out there. Unirac is one of them. This is what are called the mid clamps, and what these allow you to do is have two sets of photo PV modules side by side, kind of like this, sharing a single rail. So imagine two parallel PV modules side by side with nothing more than this clamp between them to bolt them to a single rail. That way you don't have to buy two rails for each column or row of PV modules. You could share a single bracket and use a mid clamp to clamp both PV modules at the same time. So these were purchased through the same vendor that we bought the Xantrex and the Evergreen solar modules through. That company is in Miami, Florida, and they provide pretty much everything you could need for your system in one-stop shopping. And they have very good prices on their solar modules, which is why I chose them. I am going to investigate and find out what kind of rail equipment will work with those brackets. If it has to be Unirack or if we can use Unistrut, Beeline. There's, again, many other makers out there. In addition to the individual PV array circuit breakers, we also have some 60 amp breakers, and these will go between our combiner box, I believe, and the charger. These will either protect the input of the charger or possibly the output. I haven't decided yet. One side of the charger requires a 60 amp breaker, the other side calls for a 75 amp, which is 125% of 60 amps. I believe these will come from my go between my battery circuit and the charge control units, if I'm not mistaken, because again, code requires that battery circuit be protected at 125% of the circuit's rating, which in this case is 60 amps. So that would mean this needs to go on the output of the charger. I'm sorry, I may have misstated that and said these would go on the input of the charger. These will go on the output of the battery string as it goes to the inverter. Okay, we'll have diagrams later that will show this in a little more clarity, and that'll tie it together. Basically, you've got power going into your batteries from your charger, and then power comes out of your batteries going to your inverter to feed your home. The circuit going out of your batteries to your home, don't think that's, we'll cover that later. These will cover the power going out of your battery charger to your battery string. Okay. I think we got that straight finally. Anyway, should have saved this for a separate clip. That's it for the hardware for now. There's some other equipment we have to get still, but again, I wanted a chance to look this stuff over and determine what type of hardware would be best suited for it before it was purchased, and there are some things that just aren't well gleaned from documents. Sometimes you just have to look at something, put your hands on it to get a feel for what you're dealing with, and that's what I did in this case. But you'll have the benefit of having seen us go through this before you get to that point, and you'll know beforehand. So, next time.